Hello everyone, welcome to an algebra tutorial video learning about scientific notation. In this example, we're going to learn how to take a very large number, we're going to work with Avogadro's number here, and write it in scientific notation. And it's a great application of using exponents, exponent properties in the terms of science. So let's talk a little bit. Avogadro's number is a number really used widely in chemistry, and it represents a group, or what we call a mole. And it helps scientists work with weights, masses, and understanding chemistry and chemical equations. But we're interested in the math aspect of it. We want to be able to take this large number here, 602.214.130.000, a bunch of zeros, and we want to convert it into something a little more useful, a little something that we can actually do math with, make it easier. All right, so before we dive in, we need to discuss what is scientific notation. So scientific notation, it is a way of making very, very large numbers and very, very small numbers manageable and easier to work with, and was developed as a way for scientists to do math with these very large numbers and very small numbers. But scientific notation always comes in the form like this. There's always a number a times 10. Our whole number system is based on multiples of 10 to the nth power. Now let's talk about what a and these 10 and the n and what all this means here. So a is a number between 1 and 10. And we're shortening down the large number that we're given into a single digit, or we're using all the decimal places, but we're making it between 1 and 10. So in this case, right now the decimal point for Avogadro's number is right here. But I would shorten it up. I'm going to move the decimal to right after the 6, because 6 is a number between 1 and 10. So my value for a, if I'm converting Avogadro's number into scientific notation, I'm going to have 6, and then I've moved my decimal after the 6, but I'm still going to have all my significant digits, 0, 2, 2, 1, 4, 1, 3. After the 3, everything else is 0, so I'm not going to worry about writing those. They're just placeholders. But there we go. That's how we start scientific notation. We need this number a, has to be between 1 and 10, and so we always move the decimal with our very large number to get it to fit to that. Any number, if you see a number looks like scientific notation, but it is not between 1 and 10, if it's like 13.8 or 0.95, it's not scientific notation. Okay, the next part, easy, is this whole times 10. Every place value we move here is a multiple of 10, right? Ones place, tens place, hundreds place. We multiply by 10 with our base 10 system. So if I'm moving the decimal, I have to recognize, wow, we moved it a whole bunch of tens places. So we have it multiplied by 10. So you gotta always have multiplying by 10. That's a big point of scientific notation. So it's times 10. So we got that part. The last part to figure out is this value for n. Now n is just the number of decimal places moved. How many tens places did we move it over? So number of decimal places moved. So we can see we started here and we went all the way to the 6. So how many decimal places? Well, it's 3, 6, 9, 12, just counting digits, 15, 18, 19, 20, 21, 22, 23. We moved it 23 place values. So we moved it 10 to the 23rd. There are 23 times 10, or 10 to the 20, not 23 times 10, but 23 10 times that we moved that decimal. So we would have 10 to the 23rd. And there we go. There's our number in scientific notation. That is Avogadro's number. Generally, we use it, if you see it in textbooks, it's going to be presented in scientific notation just because this is so unwieldy, so big, and not very much fun to manage in standard notation. All right, so hopefully that's a good example for you of converting a large number into scientific notation, how to go about doing that, and actually the format that we need to have for scientific notation.